All right, graph quadratics in vertex form. Okay, so this is vertex form. And what that means is we can identify the vertex really quickly when it's written like this. So they completed the square is what they did. And then they factored out any numbers that were inside and pulled. And so what you're looking at is two numbers. This number here, x plus 1, and minus 2. So minus 2, the last number in really any polynomial, is always going to be your... actually, that's kind of a lie. That's going to change with something else. Never mind. This minus 2 is how far up and down our graph is going to go. Okay, just like any typical y-intercept. So we go down to minus 2. And then the plus 1, if you remember back on the... I'll pull it out right here. And camera's wrong way. Hi, everybody. Where's the flip button? Oh, and oh, camera's not on. There we go. Sorry, I did not prepare, apparently. Where is... It's coming. All right. So the vertical shifts and the horizontal shifts. So remember, the vertical shifts is on the outside, and the horizontal is on the inside. But the horizontal is backwards. So plus means that we're going to the left, to the negative side, and negative means we're going to the right, the positive side. So identify your vertex first. So we're going to go left 1 and down 2. And that's where we are there. And then what I'm going to have you guys do is plot the point either to the left or to the right. Actually, to the right. So whatever number's to the right of our vertex is 0. Plug in 0 and see what number comes out. So 0 plus 1 is 1. 1 squared is 1. 1 times 3 is 3. 3 minus 2 is 1. Positive 1, not negative 1. And we can see that it's going up skinnier, and that's what that 3 out in front is for. It's to make our graph go up. All right. Once you get the pattern, these should go pretty quickly. So identify the vertex first, whenever that pops up. Okay. So we have negative 4, so we're going to the right 4. And then we go up 3. So the vertex. And I'm going to plot the point right into the right. So 5, we're going to plug in 5. So 5 minus 4 is 1. 1 squared is 1. 1 times 3 halves is 3 halves plus 3. Okay, so I'll go to the board for this one. I think I might be going a little too fast in my head. And okay, so write it down. All right, so we're plugging in 5. So 5 minus 4 squared, 3 halves, plus 3. This is 1. 1 squared is 1. 3 halves times 1 is 3 halves, plus 3. 3 can be rewritten as 9 over 3. Sorry, that's a mistake. It should be over 2. So we're going to go 6 over 2. 3 plus 6 is 9 over 2. So 9 halves. Hopefully we can plot 9 halves, which is 4.5. It does not let me do that. Okay. So since we can't do that, let's plot one more point to the right. And hopefully if we go 2 to the right, this half will multiply out. So we'll plug in 6 now. All right. So 6 goes in here. 6 minus 4 is 2. 2 squared is 4. Okay, so this becomes 4. 4 times 3 is 12 over 2 is, that's 6 right here. And then we're adding 3, so we're going to have 9. So 6 plus 3 is 9. So 6 goes to 9. And that's right. Okay, one more question, and we'll call it good. I already did one before this, so we only had 3 set up anyways. So here's our, good morning. Here is our vertex is negative 4 plus 5. So we're going to go to the right 4 and up 5. And then we're going to plug in a number. I'm going to pick 5. 5 minus 4 is 1. 1 squared is 1. 1 times 2 is 2. 2 plus 5 is 7. So we're going up to 7. If you might be figuring this out by just how we've been graphing, but if you go 1 to the right, we're going to go up as many as this number is right here. So 1, and then we go up 2. Another little easy way to figure out the problem. That's how fast we're going up. Typically, you just go up 1, 1. But when we have a multiplier out front, it's going to go up where that number is. So it's 2, so we're going to go up to 2. And we are done.